Good afternoon. I'm on site here at Embedded World 2023, and joining me today is Espen Krangnes, Staff Marketing Manager at Microchip. We're going to be talking about Microchip's Curiosity Board. So, could you start by giving us an introduction to yourself?
Well, thank you for having me. First of all, my name is Espen. I come from Norway, hence the funny accent too. I took my master's degree in engineering cybernetics at the University in Trondheim, NTNU. Then started working at Atmel, working with software, working with hardware, working with a lot of different areas within the development lifecycle. And now I work as marketing manager for all our PICs and AVRs.
Okay, well, now let's hear a bit more about Microchip. Can you tell us about them?
What's Microchip? We're a lot of things. We're a big company, right? And we have a lot of different customers with a lot of different varied needs. The one thing that fits one customer doesn't necessarily fit the other. There's big customers, there's small customers. There's customers with a very defined set of needs, you might say. Others are more exploring, developing on the bleeding edge. So there's a huge variety, both with respect to customer size, traits, and features, and then whatnot. And we try to serve all of them, right? And so we're a big company. We provide a lot of different solutions that go into the gazillion different areas. And for us, we've been working with PIC and AVR for the last decades, so to speak. So we've gone through a lot of different cycles and a lot of different applications and products. And I guess the common factor is there is no common factor. It's a big varied set of customers.
Okay, great. Well, we're going to talk about your Curiosity Nano board development platform. So why don't you just give us a rundown of that?
Yeah. Well, the Curiosity Nano is basically a programmable sample. That's what we called it in-house before we released it. So the platform itself consists of a piece of PCB. There's a dedicated device on it, right? So whatever device you're developing with, there will be a Curiosity Nano for that, right? And we do this for all our different products. On the sides, you can see there's a breakout for all the different pins. So we call it a programmable sample in-house, and that's basically what it is, because it gives you access to almost every single pin there is on the micro itself. It comes in a varied set of lengths, depending on how many pins you actually have to route out, how many I/O pins and communication ports there are on a given micro. It has a staggered header, so you can take a standard 100mm header, squeeze it in, no soldering required, and plug it into your breadboard or your baseboard, whatever you want to do your development. And to do your development, we have an onboard programmer and debugger. And there's a USB-C connector on there that provides power to the board. You can debug through it. There's a USB-C to C class that provides you real-time data that you can analyze and stream in real time and display on your development computer. And for input, we've kept it pretty basic. There's a button and there's a LED. But beyond that, customers are free to explore whatever solutions they would like to do. And that's really the point of it. Give people the access to every single resource using microcontroller to develop their application, whatever it might be.
Okay, well, you mentioned developing application. Could you give an example of some of its in use?
Yeah, no, there's many ways of using it, right? One thing is doing the traditional programming, like you could do with compiling a binary or a hex file or L file inside MPLAB X or another IDE and downloading it via the embedded programmer. But we also have a USB mass storage device, so we don't really need to relate to the programming part of it. If you plug it into your computer, it will show up as a USB mass storage device. And once you got the bind that you want to program, just drag and drop it over the mass storage device, and you're ready to go.
Okay. Well, I was wondering if you could give us a brief rundown of what some of the nanoboards included in the development platform are capable of.
Well, we standardize this as the development board for our different micros, right? And there's a lot of the basic services that goes into any type of application. There's typically a communication need. There's typically an analog need. There's some timer needs. And all of these are routed out through the different pins. And given the different sizes of boards, there's different sections of them. And typical signals that are grouped together by function, whether they're digital, analog, or others, have their dedicated areas on the board itself. And then by taking this and putting into a breadboard or putting into an expansion board to add additional capabilities and differentiation to them, that's where customers can create their own application to do the rapid prototyping, right? Because this provides the foundation to run the different pieces of software and applications that you like to do, but the access to all of those functionality comes through the pins and the ecosystem around it that you can proliferate and put in the features that you need to put your rapid development system up and running, or wherever you might be.
Okay, all right, great. Well, can you tell me how the nanoboards interact with the development platform?
They are fully integrated. So when you plug them in, they're detected. And when you plug it in, there's a serial number on them or an ID. You say, hey, this is the Curiosity Nano that you plugged in, the AVRDB or the PIC Q43 or whatever it might be. And, hey, this is the board. You'll get the schematics, you'll get the user guide, you'll get the example applications, and then you're up and running, right? You want to take advantage of some of those? Do you want to develop something on your own, or do you want to download an example through Discover or somewhere else to pipe it onto your board, program it, and then you're ready to go?
Okay, great. Well, what's the kind of data that can be collected with all this combination of boards?
There's a lot of data that goes that can come out of it, right? And one thing is the basic debugging that a lot of people are used to, whether it be traditional bitbang, that hey, light the LED, I've reached this point in my source code, right? Or you can put a trigger point inside the IDE, say, hey, please stop executing when you reach this line. And that's a traditional way of doing it. But with the Curiosity Nanos, we're taking a step further. We have a USB-C-to-C class there that provides real-time data to something we call the data visualizer. That's a plugin. You can have it inside the IDE. You can have it as a standalone entity if you'd like to do that, and plot in real-time data values of an ABC conversion or a UART string or whatever, and pipe it out of there and pipe it straight into the computer, and you can analyze it. You can download it, do it in real time, or do it offline, or pipe it somewhere else. So that's some of the real-time data capabilities that's built into the Curiosity platform.
Okay, great. And maybe we could move on Curiosity nanoboards for clickboards, if you could explain that.
Yeah. No, and clickboards are essential for us to be able to provide differentiation. There's only so much you can do with a button and a LED, right? So you'd like to have something else to either gather data as a sensor or an actuator to move a motor, or some communication with a wireless, Bluetooth, wireless, 5G, whatever. And all of these different things, something that's important to one customer might not be important to another one. But to have an environment, a platform that enables customers to rapid put this together, put all these different Lego blocks together and create the perfect system for them, that's really what it's all about. So for the Curiosity Nanos themselves, for the parts, that's one thing. But we have a Curiosity Nano base that the boards will plug into, with click headers that go into it. You can cherry pick the click headers that's appropriate for your application, whether it's Bluetooth or Wi-Fi, maybe it's a DC motor, a stepper motor, maybe it's a moisture sensor or a distance sensor to trigger all it, and assemble that perfect system that you're looking to develop. Rapid prototyping, you can easily see that your system is up and running.
Okay, well, fantastic. Why should someone choose a Curiosity nanoboard for prototyping and design?
It's by far the easiest way to get going. Everything you need to get going is hosted on the board itself. You plug in the USB cable and you're ready to go. And the programmer and debugger is there, the target micro is there. You have access to every single pin on the microcontroller. So I find it hard to make it easier than that, to be perfectly honest.
Why did you decide to make a development platform for your nanoboards?
Well, it's always been this debate, how do you do a development board? How do you do an eval board, right? Because all microcontrollers are stuffed full with features. There's communications, there's timers, there's serial, there's analog, there's whatnot. There's stuffed full of peripherals. And if you like to exercise them, use them in a setting, well, you need to populate them with something like a sensor, an actuator, or what you need to create your system. But the more you do populate a board with different sensors and actuators, the less degrees of freedom you get, right? Because one size does not necessarily fit all. And I think in our experience, one size only fits one customer, and it's tens of thousands of customers, right? And they all have their different twists. They all would like to differentiate. They all have their ideas. They all have their special sauce they like to add to it. So it's a little bit different. So for us to create one setup that will function for everybody, just can't be done. And by making one choice, you're excluding a lot of others that other customers might want to use, right? So having a platform that's flexible, that supports rapid prototyping, that allows the customer to build their perfect development pieces with Lego blocks, basically, it's really what our customer has been asking for.
Oh yeah, certainly. And what industries do you see utilizing the platform?
What industry doesn't utilize them? I guess I would reframe the question too. I mean, very straight off the bat, makers come to mind, right? People who put things together back in their home garage from home automation project or some other crazy idea that they might have been cooking students and whatnot, right? But I see this as something that all of the tier one use as well, right? I have this product that's been out in the field for 20 years. You know what? Can I add this functionality to it? Can I do this with it? Would this make it better? I got this crazy idea that what if we go down this path, and to give that flexibility and that option to rapidly test that thesis out. Yeah, some of these things do not come to fruition. Some of these are bad ideas, but some of them are great ideas that will make the product go in a completely different direction than you actually planned. And having the opportunity to rapidly put something together and test that and really see whether it holds water or not is something that the tier ones and the biggest companies in the world do, as the makers and students and everyone in between.
Excellent. And how has your relationship and partnership with Digi-Key helped the development of these nano boards?
A lot. And Digi-Key has been our partners for decades now. And we've been together with many different types of customers, but in particular for the long tail type of customers who are looking to put systems together themselves, to see that things actually work, be able to cherry pick and set up a combination of the different features to provide something brand new, to develop something brand new, and be able to reach out to them and have a solution that they can pick up there and then and put together the system that they've been dreaming of, or that they think will make a huge difference. That's really made a difference for us as well, and that's why the Curiosity Nanos are there today.
Oh, excellent. Fantastic. It's been great speaking with you, Espen, and thank you for your insights, and I hope you enjoy the rest of the show.
Thank you for having me. It's been a pleasure.
Thank you.
Thank you.